Well, thank you all for coming today. I hope that this brief seminar meets your expectations. I'm always a little bit awed when I'm standing in front of a group of people that have much more scientific credibility than I do. So I'm not really going to give you a scientific perspective at all. What I am is a businessman who's working in the area of greenhouse gas management to bring a business proposition to governmental units, corporations, and other organizations. The perspective of this is going to be strictly from the business angle, so I hope to lead you through a series of conversations. Please don't hesitate to ask questions. We should be wrapped up here by 1 o'clock with no problem. Again, sort of following on the introduction here, I want to just give you a little bit of my background so you understand my perspective. I've been in agriculture for the last 25 years, principally in the area of commodity trading, but also working in international trade supply chain and logistics, so I have a lot of transportation background, and then more recently getting into the biofuels, biomethane, landfill gas type projects as related to agriculture. And that led me to this common thread of carbon that runs through all of these renewable energy areas. So when I left my last employment at the end of 2006, I decided that I would explore at least the business opportunity in this area. And in fact, were it not for the economic situation that we're in right now, we'd be having tremendous success, particularly with the advent of this new administration. But as it is, we have a lot of interest primarily from companies and from governmental units that are interested in learning how to reduce their greenhouse gas emissions and having that conversation. So I approach this whole area from a standpoint of risk management, opportunity capture, and supply chain. A couple of advertisements. That's my quid pro quo for being here. Again, we formed this back in April of 2007. We're headquartered in Stillwater, Minnesota. We've got a field office in Broadus, Montana. Anybody know where that is? Wow, must be a motorcycle rider. It's about the only way anybody gets out there. And we also have a field representative in Washington, D.C. that helps us stay on top of some of the policy issues. Our entire focus is helping our clients identify and manage their carbon risks and opportunities. We're still using a shotgun. We haven't found the rich vein of interest in this area yet. So if you hold up your hand and you're willing to send a check to us, we're basically yours. We're not shy about advertising that we take on all comers at this point in time. I do believe that there will be some emerging areas, even outside of the regulatory framework in the voluntary space that are going to become important, but we haven't discovered exactly which ones those are. So you can see the sort of wide dispersion of our customer base right now. All of these are two-peats. None of them are three-peats. So just gives you an idea of how broad but shallow the market space is for us right now. So as we talk about, the business concept here, what we try to get people to focus on is my technology. Okay. We've got a dual issue when we talk about carbon. Beginning in about the middle of the 1800s, man unlocked this wonderful potential in fossil fuels. It's what's driven us this far. It's a relatively cheap source of energy when you don't include the environmental service component, and the benefits of this to society have been unbelievable. But as we've continued to use fossil fuels, what we've done is we've released more and more greenhouse gases into the atmosphere. Simultaneously, what we've done through our built environment and through our agricultural practices globally, is we've reduced the natural ability of the system. I'm not getting much cooperation here. We've reduced the natural ability of the system to do sequestration. So if you take a look back over 400,000 years of data that's presented through the Vostok ice cores, they have a very good idea of what the concentrations were of greenhouse gases in the atmosphere on an annual basis, along with what the temperature patterns were for that annual period. During that entire 400,000 year period, greenhouse gas concentration, CO2 in particular, never reached over 280 parts per million. There was a natural balance going on. Although there was a cycle, about every 100,000 years, there was a cycle of an increase in temperatures and an increase in CO2 concentrations. There were some boundaries to that cycle, and it never reached above 280 parts per million. So the natural system seemed to work well. The self-correcting mechanisms seem to work well. We've compromised the system, again, in two ways so far. We continue to emit higher levels than natural of greenhouse gases, and we continue to compromise the natural system's ability to sequester those gases. So there's a supply solution. It's on the horizon. We've relied increasingly on fossil fuels over the period of time that I described, since basically the middle of the 1800s. At some point in time, probably about the end of this century, we will probably return to primarily a renewable system. Just by the very nature of the fact that fossil fuels are limited, we will probably use up just about all the fossil fuel sources that we have. I think we will wind up using them all by the time this is over, at least the ones that we can get to conveniently and economically. But I think through the course of the next 100 years, and I do think it's going to take that long, we should revert from an entirely fossil-based system, which essentially we have right now, to an entirely renewable-based system. So there's a supply solution on the horizon. But I think it is 100 years out before we are able to move from that fossil to that renewable state. So the question is, what do we do in the meantime? How do we develop a system in our economic structure and in our day-to-day activity that addresses not only the supply side, which is under development, but in my opinion, it's a demand solution that we have to develop. So the demand solution is based on behavior, it's based on energy efficiency, it's based on technology that allows us to capture gases and perhaps sequester them or put them into other uses. We drive this through our investment pattern. We drive it through our understanding of how our health is related to the environment. We go from sort of a consumptive model to a satisfaction model. We believe that the demand side is going to be the bridge between here and the supply side solution. It's going to have to be intentional, though. We're not just going to get there by waking up in the morning and saying, okay, this is what I'm going to do. It's going to have to be a system where we have set a set of laws, a set of regulations, and a set of behavioral thinking that gets us through the demand component of this to reach that supply solution. I mean, I can envision 100 years from now when we don't really concern ourselves with how much energy we're using, because I think we'll be able to supply that energy on a very clean basis, very economically. But between now and then, we have to have demand solutions built into our model. Yes, sir?
Does that mean you think renewables is going to take the place of fossil in terms of the actual energy content?
Yeah. Yeah, but it's 100 years out.
So all that we're using now will be able to use 100 years from now renewables?
In my opinion, I don't know that we have a choice. Whether it's 100 years, whether it's 75 years, or whether it's 125 years. I mean, we're chewing through vast quantities of fossil fuels right now. And we may unlock more.
But if we conserve, we don't need to burn.
Correct. Correct.
You think renewable will not take it up to the calories that we're burning?
Well, I don't know.
Okay, well,
I mean, what does the population look like 100 years from now? Even if we conserve, we may be at the same total energy need 100 years from now, even with heavy conservation. But I don't believe that there's going to be much fossil source left for us to use. So we're going to have choices to make between efficiency and between renewable sources. But my point is that to demonstrate that I do think it's 100 years away. So I don't think we should look for supply solutions to be a quick fix to anything. Those technologies are going to take a long time to develop, a long time to implement, and I think we still have energy models to create that have not yet been created in the forms of distributive power and things like that. Third world countries, I think, are going to leapfrog technology, just like they did with cell phones, right? If you go to China right now and you get off the airplane, you go 1,000 miles inland, your cell phone works better than it does driving through Wisconsin. Now, Wisconsin may be a bad example because they have notoriously bad cell phone connectivity up there. But I do think that we're going to see these leapfrog of technologies so that economies that today don't enjoy the benefits of heavy industrialization, heavy energy use that we enjoy, are going to be able to implement new models that will be clean models from the start. And they won't ever use the kind of fossil resources that we've been using to get to where we are so far. So again, moving from a fossil to a renewable system. Now, in my opinion, there's just a few small things that we can do. Now, I don't mean to make them sound like they're easy, but they're relatively easy to explain. Energy efficiency, product design, transportation planning, energy choices, and waste management, along with land use and natural resource management. So again, we're attending to both sides of this. We're attending to the emission curve going up, and we're attending to the sequestration curve going down. I don't think either one of those solutions alone is going to resolve the question of increase in atmospheric concentrations of greenhouse gases. They have to both be attended to at the same time. Again, the goal is to bring the system back into some sort of balance. So we propose the green pathway, right? We're going to take a left and a right off these red pathways, and we're going to go straight forward with a combination of the reduction in greenhouse gas emissions and the increase in greenhouse gas sequestration. This is something that when I was putting my head around this, and I've presented this in other forums as well, I see that there are 4 environments out there that we need to attend to. I'm going to briefly go through the built environment, the operating environment, and the natural environment today. The human environment is a behavioral thing that I chose not to present today in order to save some time. I presented that to some other organizations. The built environment is essentially our big bogey right now. The built environment is responsible for the majority of our greenhouse gas emissions and the majority of our greenhouse gas sequestration reductions. And you see how complicated it is. It touches us every single day when we wake up. Everything that we do is around the built environment, getting from one built environment to another, crossing a highway, going down train tracks, that's all part of the built environment. Again, compromising natural services and also making us rely on transportation to get from point to point. But the residential, industrial, and commercial built environment is the largest component of our economy in terms of its contribution to greenhouse gas emissions. By sector, buildings are number 1. Many people think that that's unusual. They think that transportation must be number 1. But when you take a look at the power consumed, just the power consumed actually, in buildings, that those type of scope 2 emissions that are actually created upstream from the building to create the electricity and bring the energy into the system are the largest sources of greenhouse gases, far ahead of industry and slightly ahead of transportation. In the U.S., the impact of buildings on resources, 40% of our primary energy use is caused by our occupation and use of buildings, 72% of our electricity consumption and the concurrent CO2 emissions that come along with that electricity consumption and energy usage. So I had a lot of fun making this. I don't know, does anybody here use Keynote? Anybody else a Mac user? I just have a great time using that. I'm always scared it's not going to show up very well when I get into a forum to present. But what I tried to do here is I tried to think through in a big picture way what our operating environment looks like. In general, it comes from a set of resources that we deploy. We transport those resources. It goes through a series of manufacturing and then goes into disposal systems. And the land and the air and the water that we use as resources are often also the recipients of that disposal. So we've created a closed loop environment that compromises the various things that we actually need to use. Recycling has helped, but it's not going to supply us out of this situation. At a more granular level, today, just about everything that we do starts with fossil sources. I mean, renewables are up and coming, but we are still 90% plus reliant on fossil sources. They provide all of our chemical production, most of our chemical production, virtually all of our vehicle fuels, our electricity, our on-site combustion, and that's pulled by that demand sector that I talked about before. All of our residential, commercial, and industrial building demand, the stuff that we discard contains those materials, the stuff we buy and use. All of our primary building materials, construction materials like metal, cement, plastic, and paper, are heavily reliant on fossil sources. Now we can, and I think we will, do this. I don't think the system has to change once the renewable side of this is plugged into place. People talk about having to change lifestyles a lot. I do think we are going to have to change lifestyles through this demand management piece. But when we pop out the other end, when we pop out into primarily a renewable system, I could make the argument that it could be sort of business as usual. But again, that's a long ways away. So I tried to depict here in the natural environment is the biosphere in the green, the hydrosphere in the blue, the geosphere in the brown, and the atmosphere in the light blue, with people at the middle. Because there's an interactivity between people and all these various components of the environment. Those yellow arrows represent what I would call environmental services. It's our value that we extract out of our use of those various environmental elements. Heretofore, we've been basically charging ourselves very little for those environmental services. We use water relatively inexpensively. We don't charge ourselves the full cost of the water use. We don't charge ourselves the full cost of the atmospheric use or of the land use. And I've heard it said that if we tried to replace natural services in terms of what they provide us, that it would cost 3 times global GDP in order to do that. If we were trying to reconstruct environmental services so that they provided us with the same level of value that the natural environment provides us today, that it would cost 3 times global GDP. As time has gone on, we've compromised the biosphere, primarily through our building as well as our agricultural practices. Still going on today in many parts of the world. Brazil still has a highly compromised biosphere because of the increase in farming. Areas in Southeast Asia have a highly compromised biosphere because of the removal of natural sequestration sinks, such as the tropical forests, and replacement with things like palm plantations, which are used then to make biodiesel. So we're still actively compromising the biosphere. The hydrosphere is compromised. We've seen an increase in acidity in the hydrosphere. All waters, particularly the oceans, are measured now at a higher rate of acidity. We don't know where the natural boundary of that system is, but clearly the hydrosphere is under stress. The atmosphere, as we've talked about, is the recipient of all of our greenhouse gases. Those have an amazingly long lifetime, depending upon which gas you're talking about. So the atmosphere itself has a limited absorption capacity in terms of its ability to provide environmental services for us, such as the appropriate amount of warming without having too much warming. And meanwhile, the population continues to grow. So it's a complicated situation. It's a complicated situation. So as that sort of as a backdrop, I want to talk a little bit about how do we measure carbon and why do we measure it? Carbon's the proxy, right? There's 6 greenhouse gases in the Kyoto Protocol, but they all get equivalated to a carbon measurement. So carbon's the proxy. So every time you hear the term carbon, we mean carbon dioxide, we mean greenhouse gas emissions. But in terms of measuring carbon emissions, we basically take 2 approaches. We take a life cycle approach on a product basis. Think cradle to grave or cradle to cradle, sort of the new discussion about this. All the inputs that go into the materials that we use and the activities that we have potentially a carbon emission component to it. So if you try to stack those end on end or top to bottom, you come up with a carbon life cycle assessment of a product. And we use this aggressively for certain organizations right now that want to come to understand the true life cycle of the products that they're producing. It's a lot of data collection. I'll show you a slide in a minute about more about that process. Similar to that, but slightly different, is an emissions inventory. We think about that sort of as a vertical pipe, whereas the life cycle assessment is more of a horizontal exercise. The life cycle is from beginning to end, and emissions inventory is sort of a state of affairs at a particular location or for a particular enterprise. Emissions inventories are usually used to measure transportation, other processes as opposed to products. And then at the project level, if you wanted to do an analysis at a project level, so let's say we're going to build a new building or put in a new plant somewhere or switch out equipment in a plant, we would use a combination of life cycle assessment for the materials that we're using and an emissions inventory for the building that we're building, how we're going to occupy that and how we're going to use it. Again, we use a term called global warming potential to express in carbon dioxide equivalents, that's what the small e means at the end of CO2, so that we can have a normalized conversation around sort of one element here. These global warming potentials that are expressed in the right column are the measurements that we use today, and these are subject to change as more scientific work is done. But basically you see methane at 23 times. So that means a ton of methane is equivalent to 23 tons of CO2 in terms of its global warming potential. And so forth and so on, down to 22,000 times. Now, thankfully, there's not much sulfur hexafluoride that we have to deal with, at 22,200 times carbon dioxide's global warming potential. But nonetheless, these are the 6 greenhouse gases that we're focused on today under the leadership of the Kyoto Protocol. That may get expanded. There's a meeting in Copenhagen in December that's going to be, with any luck at all, is going to be the meeting that decides what the post-Kyoto world looks like, beginning in January 1st of 2013. They may increase the scope of these gases to be, I've seen 2 different charts. One that there would be 9 gases, and the other one that there would be 10 gases. But right now, this is what we're talking about when we're talking about greenhouse gases. So the basic process that we go through, if you're a client of mine, if you're a corporate client of mine, and we want to find out either on a product level or on a process level or on an enterprise level, what is your greenhouse gas impact? We go through the same process with everybody. The first question is, what are the boundaries of the exercise, right? I can't begin infinitely this way, and I can't end infinitely this way. So what's appropriate for my assessment, whether I'm doing an emissions inventory on an enterprise or whether I'm doing a life cycle assessment on a product? We help answer that question. It's usually informed through a stakeholder analysis. Usually you're talking to me, if you're my client, because somebody's pulling your chain in this area. You're hearing from customers, or you're hearing from your board of directors, or you're hearing from investors, you're hearing from your banks. They want to know what your greenhouse gas plan is. Well, in order to have a plan, you have to really start out with where you are, and then you can plan from that point. In order to start out from where you are, you have to establish appropriate boundaries. So we guide the client through this primary discussion about setting boundaries for the exercise. And then we talk about scopes. Scope 1, Scope 2, and Scope 3 emissions. I'll talk about that a little bit more, but basically everybody all the time has Scope 2 and Scope 3 emissions. Larger industrial outputs involve Scope 1 emissions. But even at the furnace in your house, if you're on natural gas, you have at least a minor Scope 1 emission. I'll talk a little bit more about that in just a minute. But not all scopes are appropriate for all emissions inventory exercises. So we help the client first choose the boundaries of the exercise and then choose the scopes that are to be considered. Then we go through a data collection process. This is primary data collection. We use various coefficients, emission coefficients, along with that primary data. And that spits out essentially a carbon dioxide equivalent calculation for that client based on the scopes and boundaries that we set for that client with their help. Organizational boundaries are approached sort of in one of 2 ways. The equity approach, in other words, what does the organization own, either all or part of, or what does the organization control? You can imagine that there are plenty of organizations out there that do third-party manufacturing, for example. They may actually control that site without owning it. In some cases, it's appropriate to bring that in to the emissions calculation. In other cases, it may not be. We go back and forth, and we had this conversation with the client about what's appropriate for them. And the operational boundaries are sort of, okay, once we've determined the equity or control approach, now we come in and we slice up the organization, because ideally, the company is going to walk away from this with a tool that they can use. They're not just trying to create a report that they can hand off to somebody else. We want them to have a real-time tool that they can use, so they have to break it down to sort of operating units within the organization. They can assign management responsibility. They can do things in terms of specific technology upgrades. So we try to go from the question of equity or control and then go inside the organization and slice and dice it. And we typically follow what their normal accounting practice is. So they account for things on a unit by unit, business unit by business unit basis, right? We're trying to give them a similar measurement. So again, they can pass this off to management, and management can have some control about their greenhouse gas emissions in the future. There's always savings here. I mean, it's fascinating to me why organizations have sort of forgotten about energy management as an active part of their cost savings measure. Why did we have to get into a conversation about greenhouse gases before energy management got back on the table? But when we go through these, either life cycle assessment or through an emissions inventory, we always illuminate what's the underlying cause of this, and largely it's energy use. We can always find low-hanging fruit. There's never been an organization that we've worked with that hasn't moved away from this exercise with cost savings through reduction in energy use and a concomitant reduction in their greenhouse gas emissions. It's more compelling, actually, for me today, in today's economic environment, to push energy management than it is to push greenhouse gas management. But when we look at it this way, we give them a slightly different view, and they go, wow, I didn't understand that before. And they're usually talking about their energy management or lack thereof. So again, back to the scopes piece. Scope 1 emissions are basically combustion on site. Or if your organization owns a fleet of vehicles, that would also be considered a Scope 1 emission. So anytime you're burning a fuel on site, that's a Scope 1 emission. Coal-fired power plants are a large Scope 1 greenhouse gas emitter, as is the cement industry, the aluminum industry, and other heavy industrial sectors. You and I are Scope 1 emitters at the furnace level. Yep.
Is sulfur hexafluoride a byproduct of uranium enrichment? Where's that?
Can somebody in this room answer that? I don't know. I don't know. I have never actually, and so far in the work that we've done, we haven't ever actually run into sulfur hexafluoride. Does anybody know? Yes, sir.
I think it's in black screens, the ones that are supposed to save a lot more energy, but the high content of that.
So high-end electronics, that sort of thing? The screen itself. Okay.
I think it's used in air production. And I think it also comes from some sort of electrical gear.
So it's used as a cooling agent. Okay. Well, again, so far we haven't run across that. Otherwise, I would have been able to answer that question.
Right. Now you know.
Now I know. So again, Scope 1 emissions are large combustion on-site and or the combustion in your vehicle fleet. Scope 2 emissions are what most of us are primarily responsible for. Scope 2 emissions, every time you throw on a light switch, you're creating a Scope 2 emission. It's happening upstream from you at the power plant, primarily coal-fired, some natural gas for peak. But that's called a Scope 2 emission. You're responsible for your Scope 2 emissions. Now, in order to avoid double counting, okay, on a systemic level, there are exercises to subtract the Scope 2 emissions from the Scope 1 emissions in the power sector. So we don't wind up calculating those twice, right? So on a national level, they go through an exercise of pluses and minuses through all these various scopes, so we wind up with one number that makes sense. Scope 3 is just about anything else you can think of. It's the materials that you use in your office. It's the commuting that you do. It's the business travel that you go through. It's how you dispose of your waste. There's an awful lot of components that go into Scope 3. It's considered the most optional scope component to use in your calculation. Progressive organizations are digging into this. They're actually doing switching between the organization and the individual. An example is the University of New Hampshire, I believe, decided to take the Scope 3 emissions of their students commuting to class every day and create a mass transit system with their own fleet that internalized it at the institutional level as a Scope 1 emission. And you're saying, well, why would they want to bring more emissions on? Because the net exercise was a total reduction in carbon dioxide when they removed all the cars from the road that the students were driving and put them in light rail, buses, and other sort of mass transit. So on a systemic level, greenhouse gases dropped, but there was a switching between entities, if you will, of these various scopes. They went from an individual Scope 3 to an organizational level Scope 1 emission. And so these things, when you track them over time, there's a very interesting component to this because your baseline can move, right? Your baseline from the first year you do this can change depending upon how you exchange these scopes with various counterparties that you're working with. And air travel is also a part of this. Any questions so far? So again, our goal is to get to CO2 equivalence. What we start out with, and this is where usually the client, is just overwhelmed. We've got all these data points out there. It looks like a mess. How do you aggregate these data points? Well, again, we start out with the boundary question, right? That helps put a box around it. And then we go to the scope question. That helps refine it a little bit more. And then there are some common sense elements to this. I mean, we've got long lists of potential data points at this point in time because we've done several emissions for clients. But this is the area that scares a lot of organizations. And where they don't get it right is they make assumptions without having gone through the boundary question and the scope question ahead of time. That's primary data identification. And then we pick up that primary data, right, and stick it into a data assembly software tool that we use. That primary data is basically telling you a lot about your energy usage, a lot about your materials usage, but it's not yet informing you about carbon dioxide or your greenhouse gas emissions. So we have that primary data, and then we use emission coefficients to transfer, or translate, I should say, that primary data into greenhouse gas data. For electricity, for example, the EPA publishes something they call eGrid. So on a state-by-state basis, you can go and see more or less what the mix of various electrical sources are in your state. Coal, wind, hydro, solar, biomass. It's not a perfect exercise, nor is it static. But the EPA has at least provided a tool that if you wanted to do a cursory examination of your greenhouse gas emissions at a personal level, you call up your utility, get your natural gas usage. There's a coefficient for that, and then get your electricity usage. And if you go to EPA eGrid and look up your state, you can take your energy used, kilowatt hours, compare it to the information they give you for your state, and you'll be maybe 85% accurate. It costs a lot of money sometimes to get from 85 to 100%. So this is a good broad tool that you can use for yourself. Much more complicated and somewhat controversial are other coefficient data tables that are still being developed, and I think will continue to be developed for a long time by scientific bodies around the world. So the UN, the Greenhouse Gas Protocol, World Resource Institute provide emission coefficient databases along with a slew of other sources. And with that information combined with the primary data that you've collected, you can create either your life cycle assessment or your emissions inventory at some relatively accurate level. So even you at home could do this if you were so inclined, if you wanted to do it for your organization. Again, it's primary data plus emission coefficients. So now you've collected all of that information. Now it's sort of the so what, right? Particularly here in the U.S., we're in a voluntary system, meaning there is no compulsion to measure greenhouse gas output other than coal-fired power plants in the Northeast who have recently started under the Regional Greenhouse Gas Initiative, their own little micro cap and trade system. I'm going to make the argument that I think market signals are critical here. I mean, we really only understand one market signal, and that's price. So whether it happens through a cap and trade system, or it happens through a carbon tax system, or some combination of the two, until we actually attach a price, both on an incentive basis and on a penalty basis, to behavior that creates greenhouse gas emissions, we're not going to start getting a solution put together on this. Our traditional market signals fail us. Look at the run-up in petroleum and other fossil fuels last year, and then the crash in that. You saw a lot of, at least I did, I saw a lot of pickup trucks disappear, F-350s, dualies, double sets of tires on the back. I mean, these things, I can't even see the driver. They're so big. I saw a lot of those disappear from the road last fall when oil prices were high. Well, they must not have gone too far because I see them back on the road now. So our traditional market signals tend to fail us in regards to greenhouse gas emissions. They may send appropriate signals in terms of availability of fuel, but they don't send appropriate signals in terms of greenhouse gas emissions. So I think market signals, a price for environmental services, is critical to this exercise. But it must be combined with a regulatory framework. And the beauty of a cap and trade system, and whether you're a proponent of that or tax, I'll try to take you through it. The cap and trade system will absolutely, for the sectors that are chosen, will absolutely provide a cap on emissions. Well, they have to get those set right, and they have to have the progression of the dropping of that cap set right. But that cap is a cap. As opposed to a carbon tax system, when you're relying solely on price to communicate to the marketplace what the cost is. The cap and trade system will provide an absolute cap, but the price will be unknown. The beauty of a tax system is the price is known, but you're not sure what the response to that price is. So I think a cap and trade system more appropriately models the way that we work economically, more appropriately gives incentives and penalties, the way that we think economically. Now, maybe a couple generations from now, they'll move to a different way of thinking. However, a carbon tax system is elegantly simple. I mean, the concept is you tax carbon emissions from the absolute source. So it's at the mine mouth or the wellhead, and there are thousands of those, but at least you're not dealing with millions of collection points. They are discrete, known, measurable. The oil wells that are out there, the coal mines that are out there, the natural gas wells that are out there. So it's easier to tax those materials because those materials, there are known conversions for those materials to greenhouse gases. It's not a mystery. And then that price system ideally gets sent down the pipeline through to the consumer and everything that we do, and the consumer makes choices. And you can put technology into place to mitigate those costs, and the technology winners then become the drivers of the new economy. Yes, sir.
Do you assume that a port of entry is a source and we tax the oil as it comes into the country?
We would under a tax situation, you'd have to account for imports. There would have to be a concurrent tax that it wouldn't maybe go back to the wellhead, okay, or to the mine mouth, but it would go to a port of entry. That's correct. That's what's under discussion anyway under a tax situation.
Cap and trade assume that they would have to be treated the same way.
Yeah, but the cap and trade is going to be based on emissions at point of use as opposed to emissions at point of source. Right. Or not emissions at point of source, emissions that come from the materials at point of source. There's a question back here.
Well, like non-oil, a fair amount of oil, but it's very low volume compared to
Right.
the Middle East.
Right.
And that seems to be, it costs the operator a lot to produce that oil. So taxing them at a rate that taxes the Saudi Arabia is negligible.
Well, it will likely be, I mean, if a tax prevails, it will likely be on a per ton of coal, per million BTUs of natural gas, or cubic meters, or some similar measure, or per gallon of petroleum. Also adjusted for different types of coal, different types of petroleum, because they aren't all equal. But at least it's a fairly discrete exercise.
Who gets the money?
Well, under some proposals, that money would go into speeding up our renewable research. In some other proposals, that money would go to general fund. In some other proposals, that money would go to a tax rebate at the individual level, perhaps, to compensate for their increase in cost that's assumed to go along with that. That's a long ways down the road. That has not been resolved because the tax question has not been resolved. But it's part of the conversation. I mean, if you track what's going on in Congress right now, one of the big concerns from one side of the aisle is that could generate a lot of money. What's going to happen with that money? That seems to be more of a concern than the idea of a tax itself, is the growth of government that could happen with a huge influx of revenue. But the government is proposing to support everything green. So you could see that support mechanism could come from tax or auction of allowances under a cap and trade system.
What does it do to nuclear? And how does it, how will it fit with the tariff barrier? Would it be viewed as a tariff barrier?
Well, I mean, the nuclear question is also on the table from a slightly different angle. It's sort of like the ethanol question. At the tailpipe, ethanol is a great fuel. You do the life cycle assessment of ethanol, it's a different equation. Similar with nuclear. At the tailpipe, if you will, it's a great solution. But when you include particularly water use, and you include waste disposal, and you run that sort of life cycle assessment on the nuclear plant, okay?
But you're only taxing carbon here. What about those factors? How does that?
Right.
How is that figured in?
It's a good question. It probably wouldn't touch nuclear. A carbon tax would probably not touch nuclear. The way that I've seen it proposed so far. It doesn't mean there aren't other proposals being considered.
What about the second question? Would it be viewed as a tariff barrier? I mean, suppose
An internal tariff, you mean?
mean, for example, if you wanted to use, say, natural gas in plenty, but then let's say you're importing coal from a different place, then there are differences. Would all carbon of all types be taxed the same rate?
Ideally, but the part of the problem, and this sort of goes to the question over here too, part of the problem is our current WTO structure would have to be redone. The current World Trade Organization international trade structure would have to be remodeled to accommodate this. So it wouldn't be viewed as simply an invisible barrier that's being thrown up for no reason. It would have to be on a global basis. The tariffs and barriers would have to be similar, and the World Trade Organization would have to rewrite some portion of their rules or completely undo it and start from scratch to accommodate that piece. But if you didn't do that, you'd wind up with more of what we have now. You'd wind up with extraction, right, from areas that didn't have maybe an internal mechanism shipped cheaply to us, and then we haven't done anything to mitigate the problem. But there is a WTO question. There is a trade question embedded in this that hasn't been resolved either. It's very complicated. So again, the price system for environmental services, we're talking more specifically today about greenhouse gas emissions, but this goes for all environmental services. The use of land, the use of water, the use of the atmosphere. That price component is an important part of this. And that's why, I kind of call myself a stealth environmentalist. When I show up at a company, I'm not showing up wearing my green duds. I'm showing up wearing my business duds, right? I am an environmentalist, but when I screw on my business face, I have a proposition for these businesses. We think the business case is compelling. We're not trying to push an environmental thought process into their minds. Now, I do have some clients that are very environmentally oriented, in which case I'll go in my green suit on. But we've got to appeal to the business sector, because the business sector, in fact, does just about everything that we interact with. They build the buildings, they provide the transportation and fuel systems, and the only way to communicate with them, I shouldn't say the only way, I think the fastest way and the most effective way is through a price on carbon. So we're a supporter of cap and trade. We're a supporter of having a regulated system, principally around Scope 1 emissions, coupled with a voluntary system, principally around Scope 2 and Scope 3, as a starting point. And then as we become familiar with that and how that works, Scope 2 may also get included into a regulatory framework. Scope 3 is too messy, I believe, to ever get included into a regulatory framework. Again, it's your commuting, right? It's the materials that you use in your office. It's your business travel patterns. Now, there'll be price signals that will help you make those decisions, but I don't think Scope 3 emissions are going to be part of a regulated system anytime soon. So we think there's going to be a voluntary system that's very robust, much more robust than we have today. The voluntary market for carbon today is more or less $2 a ton in the U.S., compared to the regulated market in Europe, which today is more or less $15 a ton. The voluntary market's cheaper because nobody's compelled to buy carbon offsets or to buy carbon credits because there's no system compelling them to do so. But I believe by the end of this year, well, Senator Waxman claims by Memorial Day, we're going to have a cap and trade bill on the floor of the Senate. I don't know if the current legislative mess is going to let us get there. It's hard for me to believe that we're going to walk into Copenhagen next December as a willing member of this conversation now, that the administration is very focused on, without having some sort of at-home policy in our pocket. It just doesn't seem like a good negotiating position. So that's why I'm betting that this year we will see a regulatory framework proposed, at least, if not passed, that will start describing our world in the future for Scope 1 emissions and how those will be regulated. Scope 2 and Scope 3, I think, will stay in the voluntary setting. Yes, sir.
You mentioned the price on voluntary and the regulated market.
Mm-hmm.
Do you have a notion about what's good? What you might call the true value of?
No. No. I mean, the modeling that gets done, from a policy standpoint, the question is, okay, what does carbon at a certain price mean? If you run that policy forward, right? So the boundaries on that question that I've seen are $15 to $40 a ton. Not sure how they got there, okay? In Europe, we've seen prices as high as $50 a ton within the last year. In the U.S. voluntary system, we've seen prices as high as $7.50 a ton and as low as 85 cents a ton in the last year. I don't know that anybody knows the answer to that question. From a policy standpoint, they're looking at this range from $15 to $40, running that out over a period of years and seeing which elements of the economy benefit or have a detriment from those pricing levels.
Once we got these green tags, how do we verify them and where are they traded? Are they traded on the stock market?
Well, again, today there's a voluntary market on the Chicago Climate Exchange. There's also a lot of different registries around the country, which are variations on an exchange. You do projects that reduce greenhouse gas emissions or increase greenhouse gas sequestration. That scheme awards credits for that activity, and then you market them in the open market on a voluntary basis. So it's not quite like an eBay, but it's more of an open system rather than an exchange system.
But who's verifying the validity of
right.
these credits?
All of the various schemes today around carbon trading have a verifier group. So they've nominated organizations to do the verification. It looks like ANSI, the National Standards Institute, is going to be the certifier of the verifiers. So you're going to have to go through a teaching process, probably an annual review. You'll become licensed by ANSI as a verifier. So when we do projects, we do greenhouse gas sequestration projects today quite aggressively. We have about 2.5 million acres in our system right now. We've had to have all of those projects verified by a third-party verifier that's been approved by the Chicago Climate Exchange or approved by the Voluntary Carbon Standard, depending upon which scheme we're involved in. That verification is a very important part because there's always a chance, and it's still not perfect yet, there's a chance for what's called leakage, and there's a chance for slippage, and there's a chance for downright fraud. And even in Europe, where they've got a regulated system, some of these credits have traded multiple times when they were only supposed to trade once. There's been a lot of money flying around. I come from the trading world, so I can say this with some knowledge. Traders are intentionally, they're viruses, right? They exploit the weak spot in the marketplace. They arbitrage away the differences between understandings in the marketplace. So if you use that to your advantage, you watch where the traders accumulate, and you sweep away that pile of sugar and see what's actually going on down there, and then they'll reform over here, right? Traders are actually extremely, extremely efficient at finding the weaknesses in any system. And so we've seen traders exploit the weaknesses in the system. The European trading scheme and Kyoto are under phase 2 right now, which looks much tighter than phase 1 because of the weaknesses discovered in phase 1 when they watch the traders. Yes, ma'am.
Is any country moving carbon tax?
Not that I'm aware of. It doesn't mean it's not going on. Yes, sir.
In Denmark?
There's a tax system?
Yeah.
Are you outside of the EU ETS?
You put this on scope 2 and 3.
On scope 2 and 3.
It was just packaged 4 days ago.
Okay. Very interesting. So how is that interfacing then with the scope 1 regulated system?
They don't know yet. They're doing the calculations, and
Right.
it's the result of poor negotiations. That's just my personal opinion.
Got it. Yes, sir.
I can't answer all of these verification questions, but I can't help but brag about a project that's underway just 40 miles from where we sit.
Okay.
At Decatur, Illinois, an extremely well-documented experiment. 1 million tons of carbon dioxide was put in permanent storage.
Geological sequestration.
Geological sequestration.
Right.
ADM site under the scientific direction of the Illinois State Geological Survey.
Right.
The hole to do that being drilled as we sit here.
Right.
And that'll be documented in the extreme.
I was asked this question yesterday by
The feasibility of doing it.
Right.
It won't answer these cost questions. A high cost experiment. It's a big scale.
It's a big scale one. It's the largest in the U.S. And I had a Japanese client yesterday ask the question, how long before carbon capture and sequestration is a potential reality? Can you answer what the timeline is on that experiment?
In terms of this, we don't know here. The drill bit is 4,000 feet on its way down to granite as we speak. The injection starts next year, next calendar year. Put 1 million tons in, document it well. I'll now give you my brief. I'm an extremely optimistic environmentalist on this. With any luck at all, in a year or two, we'll go a step further and deal with the power generation side, future gen, when that happens, 30 miles south of here.
Right.
So the world demonstrations are right here.
Yep.
And we're, within a couple of years is only the answer.
They're sequestering CO2 elsewhere, in Europe, for a long time. It's not like this is
Yeah.
something new.
Right.
We've got one at CPOT, don't
In
we?
the geological
Yep.
community, there is no doubt that this will work. And it's, I'll almost say easy. Now, it's a $60 million permit, but we've been doing it with natural gas in underground reservoirs for decades.
Right.
This will work.
Little different.
Is
Little,
sequestration a long-term answer? I can't tell you that.
Right.
Sequestration will be demonstrated.
Right. And so under a cap and trade system, that technology would flourish.
Well, at least we'll have the
Under it.
cost of doing that, and then whether that becomes
Right,
the economic
right.
model, we'll at least have numbers on that.
Under a tax system, it wouldn't recognize that technology
Why is that?
because coal would be taxed at the mine mouth, regardless of the technology to capture it, to capture the CO2. The proposals that I've seen right now, these are some of the issues. The tax issue is elegantly simple, but it falls short of setting emission caps, and it fails to recognize downstream technologies that deal at the emission point. Yes, sir.
I'm curious if you can compare successes of sulfur dioxide systems from the 70s.
Absolutely. Right. I mean, the U.S. was actually the granddaddy of a cap and trade type scheme. In the 70s, when we started dealing with acid rain, as it affected the New England states and Europe, we came back to the coal-fired power plants, principally in the Midwest and in the Rust Belt, and put a cap and trade system in that was highly effective, cost far less than industry claimed it was going to cost. And today, the problem is essentially resolved. So it is actually the best example of an effective cap and trade system. A lot smaller problem, but it worked. There's no reason why, as we learn through a cap and trade system in greenhouse gases, that can't work also. It's just a much, much larger scale idea. Yes, sir.
Yeah, electricity here is mostly generated from coal.
Yep.
And we do it right here, a couple blocks from
Yep.
the university. So when you figure out the greenhouse gas carbon equivalent from that, you do the life cycle of the coal, and does that include the methane that's released from the coal mining operation?
You can do the life cycle on the coal, or you can do an emissions inventory on the plant, or you can combine the two. And this is where statistics have been used to tell whatever story it is you're trying to tell. I'll go back again to the ethanol example. I mean, if you measure ethanol at the tailpipe using a life cycle analysis, but just looking at the tailpipe component, it's very positive. When you run that all the way back through the farming practices, it's a different equation. So you've seen the petroleum industry and the ethanol industry use different boundaries on a life cycle analysis and on an emissions inventory to tell the story that they're trying to tell.
You're doing inventory for the capsules now, right? Or you will be?
Yeah, that's underway.
So
Yes.
what are you doing? Are you doing tailpipe or life cycle on your coal?
On the coal, there will be an emissions inventory on the facility, at least as a starting point. I mean, right now there's a lot of primary data gathering going on, but this entire framework has not been completely set up yet. Yes.
I wonder what are the negative supply shifts of the price in the market for the Chicago climate exchange? What makes the price go up and down?
Right.
I haven't breaking down cap.
Yeah.
Basically, a limited supply.
Yeah, that's a great question. In general, the people who study the reasons for price movement have claimed that the spread between energy provided by coal and energy provided by natural gas is the driver for the carbon value. Their thinking being that natural gas per kilowatt, if you will, is a much cleaner source than coal. So if natural gas prices are significantly above coal prices on a kilowatt basis, the price of carbon goes down. I'm sorry, the price of carbon goes up. If natural gas prices are similar to coal prices on a kilowatt basis, the price of carbon goes up because we're going to be using more coal. Did I say that right?
There's more carbon to be disposed of.
There's more carbon to be disposed of. So actually, it's when natural gas prices are high, coal prices are low, that you have a higher carbon price.
So that is the equivalent of infrastructure use in the
Yeah, that's a good question. I don't know. Yeah, I mean, there may be an interesting parallel there. You're talking about on the grain side?
Yeah.
Yeah, I don't know if use is the right, maybe ending stocks to something. Yeah, that's an interesting question. You may be able to use traditional models on some of this stuff and just tweak them for the necessary variables. Yes? Yeah, coal is cheap because we don't price the environmental service component of that. So when you include the mining, when you include the gas escape from the mines, when you include the transportation and the ultimate use of coal, if you priced greenhouse gases on all of those components, the price of coal would change substantially. The cost of the use of coal, when you include environmental services, would be entirely different than it is right now because we don't measure any of that. That's my whole point about having to put a price on environmental services. You're right. I don't have the number on the top of my head, no. There's a lot of work going on. I mean, this, just like this Danish thing popped up 4 days ago, this is like drinking from a fire hose. When you jump into this world and try to keep up with it, there's a lot of work going on globally. It's hard to keep up with it all. There is a lot of work going on in all these areas, though. And there's this, your soil sequestration project is another example of long-term studies of how the sequestration system works and how it can increase the absorption of CO2 out of the atmosphere. That work is, whether it's equally important, I make the argument that I think that you have to both increase the sequestration and decrease the emissions to effectively get the system back in some kind of balance. Any other questions? Yes?
Well, some of it is the reality of it. We have a lot of coal, and so
we're going to use the coal. There's no doubt about it. Yep.
At some point.
I agree.
So it's not going to be effective in taxing out of the system.
No, and to the point asked, what do you do with the tax dollars? If you use a tax or if you use a cap and trade system, does that give the right incentive to technologies like capture and storage? Or like some other stack technology that we haven't developed yet, like what was developed to answer the acid rain question, the sulfur dioxide. I mean, the policy implications are huge. The right policy could get us the right outcomes. The wrong policy could drive us absolutely in the wrong direction. And that's why it's good that the policy question is taking a long time. I think many of the parties that prior to now were on principle not engaging in that question are now engaging in the question. And I think we'll get a good outcome as a result. But I'm the eternal optimist, so.
The oil industry uses carbon in messianic floods to strip old wells. At what point do we expect them to be buying up this liquefied carbon?
Well, I think if the capture and sequestration technology proves out, that would be actually a sequestration opportunity for them, wouldn't it?
Well, I know that there's an experiment at Teapot Dome, which is an old oil field, and I don't know if they're using it for sequestration, but the oil industry, when they hit a pocket of carbon gas, they use that stuff
right.
for messianic floods. So, how much of an influence does that have on the price?
Well, if you have a cap and trade system and carbon capture and sequestration works, that's an application of what heretofore was a waste product in a positive application. So not only do you get more extraction, but then you put a cork in it. I'm oversimplifying, but you put a cork in it and it stays put, right? And again, long term, we won't know long term until we get to long term how effective that is. But there is scientific reason to believe that it should work. I mean, there are different chemical properties, obviously, to CO2 than there are to natural gas. So there's some questions there that still have to be resolved. But at least in theory, you've got a chamber that should be able to hold this gas, whether you're using it as an extraction tool or whether you're simply trying to bury the stuff. And if that's effective, the price of carbon doesn't have to go up very far, maybe. Again, because there'll be a market signal, right? There'll be an incentive. There'll be an incentive to create these technologies under a cap and trade. So whether it may not look economic today, it may not look economic today, but if you start pricing environmental services, the economics changes. Any other questions? Yes.
The carbon you produce and sell, what's the price of that get the market price. Can you go with those $2 in sequestrating one ton of carbon?
Yeah, I mean, we'd rather have the price be higher. It's a lot easier to get landowners, for example, interested in projects where they have some out-of-pocket costs and they have an administrative component. It's a lot more interesting to them at $5 a ton than it is at $2 a ton. But even at $2 a ton, we are actively and aggressively getting some good forestry projects put into place, getting some good rangeland management and grassland management projects put into place today.
Looks like you probably need to finish, but
Yep.
probably a quick question. It sounds like you obviously are a bigger fan of cap and trade than the tax regime. What do you think the chances are of those two? Which one is going to succeed?
I'd give it a 75-25 type proposition right now. 75 that we'll have a cap and trade, 25 that we'll have a carbon tax. But the conversation is still ongoing. The tax conversation is not off the table by any means. Okay, thank you very much. I appreciate it.